Hey everyone, Meteorologist Tuttle here with you. It's just a little after 12:30, so I hope you've enjoyed your lunch so far. What we're going to talk about is the threat of some more storms coming up for this afternoon, and a little recap of last night and kind of what's been out there for the last few hours. So thanks for joining me. Be sure to like and share this video, whatever platform you're watching it on, via YouTube, Facebook, Twitter, whatever it may be, and help spread the word organically for me. All right, so what we're going to do, of course, is what I always like to do, and that's get into the data. And let's see, let me get things set up here. What I first want to show you, we'll probably start with this guy here. Okay. All right. Let's see. Okay. All right. So looks like that stuff's going so far. Let me try one more thing. Okay, so last night, and of course today, we've had a lot of rainfall here across the northern parts of the state, over an inch to sometimes on near 3 inches. Same thing down south. This was like two major hit corridors, and that's because those supercell type storms down here had a lot of hail with them, and we saw some hail up to around tennis ball in some cases reported out there. So it was some good hailers as predicted. That was a big forecast for yesterday. Now, late last night after I signed off, there were a couple of tornado warnings down around the Velma area from the National Weather Service. However, I was watching those storms behind the scenes, and they just did not have any really good couplets to report. In other words, they were more of a, to be on the safe side, let's issue a tornado warning because it's dark, it's overnight, people can be sleeping. Last thing the Weather Service wants is a surprise tornado and then them not issuing the warning when they're sitting there watching the radar. So it was a little precautionary deal. I didn't see any confirmation or anything like that, so I just kind of let it go and watched it. Today, however, should be a different story. All right, so that's a look at how the rainfall's been so far. Now, today, from the National Storm Prediction Center, they've got a good chunk of Oklahoma, basically the eastern half of Oklahoma, on into the eastern sides of Texas, under the gun here for some severe weather. And later, that will extend out here into Arkansas and parts of Louisiana, etc. So the big threat will be for large hail, damaging winds, and yes, tornadoes. So you can see, if you remember last night, they've expanded. We talked about the tornado risk, and they've expanded it north and west, as we talked about in the data, even on down toward Dallas and even down toward Waco, back up to about Bryan College Station, and then points east from there. So it's kind of like the sweet spot of where the Storm Prediction Center favors the best dynamics in the atmosphere to produce potential tornadoes. Now, the wind obviously is going to be in that same area as far as wind damage goes, and also the hail damage will be in that same region as well. This kind of gives you an idea of what we're dealing with. All right, now if we take a look at kind of a closer up view of that here for Oklahoma itself, that puts central Oklahoma in the slight risk, enhanced risk just south of town down I-35 corridor, and then points in eastern Oklahoma for tornado potential medium. Hail size once again close to baseballs, and winds up around 60 to 80 miles per hour. Now, the timing on that, of course, we've already had storms out there now. Heavy rainfall, even some flash flooding may have to become a problem here, especially across the greater Oklahoma City metro area. But as we head in this time frame is going to change rapidly, because it says from 1 to 6. All right, that's a big window. In other words, we'll start to see some storms develop, probably, or at least try to, new storms in this area here by around, I'd say, 2 o'clock. And then from 2 to 3, we'll see what happens as they kind of get into this more favored zone in this region of severe magnitude. All right, so don't focus so much on the exact time or even the placement. So this is the tornado potential Wednesday. Look at the computer model data, and honestly, I-35 corridor is good. This kind of highlights where we talked about last night. If I were to be nitpicky, I would probably extend it something like this. But it's splitting hairs. That kind of covers the south end of Norman just barely. But anyway, mostly south of there is the focus. So that doesn't really change from our thinking from last night if you watched my live broadcast at that point. All right, let me get rid of some of these. No longer need those. Now we're going to focus on here is the weather map, which shows the Oklahoma mesonet, which indicates where our boundaries are. So we have an area of low pressure out here developing in southwest Oklahoma, and this low will be tracking east. All right, so that'll be the focus we're going to watch for. That'll be what kind of helps to initiate our next round of storms. Now there is a warm front that comes out of this low that kind of snakes around. It does something like this roughly. All right, so that's what a warm front looks like here to kind of draw it on the map. And then if we're going to draw the dry line development, which still hasn't quite happened yet, it's just a little bit of a wind shift line, but this is where the dry air would punch in from the southwest and be our trigger. So what we'll end up watching is this little sweet spot right in here, which is the triple point from the dry line and the warm front. And actually the cold front's on the back side of this, by the way. You can see how the cold air is starting to wrap in from the north and west. So eventually get your cold front that'll wrap in like this. All right, so this whole system will be moving off to the east. And as it gets into this little sweet spot area here for dynamics, we should start to see some bubbling cumulus into cumulonimbus clouds, and then eventually some good old-fashioned, hail-producing thunderstorms, with the potential probably for a couple of tornadoes as it approaches the I-35 corridor. So that's the situation as it looks this afternoon. So that has not changed from what we talked about last night. Here's a look at one of the high-resolution models I like, which is the Texas Tech model. And this is by 4 o'clock this afternoon, this particular panel here. Let's see if I can zoom in on this one. Kind of jives with my thinking here. So it's got that highlighted area just, like I said, just touching Norman, and then points down the south to about Paoli, Pauls Valley, north of Ardmore. So that would be the sweet spot of where it thinks tornadic thunderstorm potential resides. And it does struggle with some storms south of there. It has a hard time firing them up. Some of the models are kind of in the same boat, so it's not so much a guarantee. Why? Because we have better conditions coming in this little small region. I'll show you those here in a second. Matter of fact, we could do that with this. All right, so one of our high resolution models, this is a theta E axis. Kind of we have warm, moist, unstable air that flows to the north, and it wraps into the surface low. So the surface low by this point, this is at 4 o'clock in the afternoon. So it's got just south of the metro here. And so that's going to bring in all that unstable atmosphere back into this little corridor. So it's a channel. It's a channel of instability, as you can call it. So hence, that is a focal point for storms to develop. Plus, you also have a region of convergence, which is, in other words, and these winds actually aren't necessarily accurate as far as the current pattern. In other words, these winds may be more of an east-southeast fashion, just like they're coming in from a west-southwest fashion. So you have the best convergence in here. You have the dry line in between is what we call the dry line bulge. The bulge is where it kind of nudges out like this, and then it trails back to the southwest. That's always a sweet spot for trying to develop because of best convergence in both the wind field and in moisture convergence to get some storms to go. So that's why it's very close to Oklahoma City Metro, but just south. So in other words, I think again Norman is probably the most northern frontier as far as potential tornadic development. Now you can kind of look at this at the rain that we had this morning. We had a quick thunderstorm that went through Oklahoma City not long ago, produced some good hail. I think reports around 1 inch to about 1.5 inches. So that's just under golf ball size here for most regions here over central Oklahoma City and central Oklahoma County as these kind of developed and moved to the east. But the other thing that they did is, you see this little boundary right here? Let me change this color. Think of this as kind of like a cold front. It's a cold pool. All right, it's basically an area of cold, dense air from the rain that continues to shove southward. Now, if you're north of this boundary, you don't have to worry about tornadoes, and that's what's good about it. Now, at some point here, it's going to stall, probably a little bit more than where it is now, because the upper system is still going to try to pull warm air back to the north. So it's going to be a battle zone. Think of it like a mini cold front. So kind of like what we talk about when we talk about cold fronts and warm fronts. Typically, a warm front, if we were to draw this as a warm front, would move to the north, or sometimes can be stationary. Just like a cold front that we could draw on the same line would move southward until it becomes stationary. So when it becomes a stationary cold front, we draw it usually on a weather map of blue, then red, then blue. And that's how we denote the fact that boundaries just kind of aimlessly, it's either sitting still or just kind of meandering back and forth. So as long as this boundary stays south of the Norman region, which again is right here. Close call. That puts all the severe weather along and south of this boundary. So that's why I'm saying the southern end of Norman is kind of on the northern fringe of this activity. So we'll have to watch and see what happens. But what about the rest of Oklahoma City? Unfortunately, when you're north of that kind of warm front boundary, you get stuck in this zone, which is kind of where we are now, which is elevated showers and thunderstorms that continue to develop. So you can get some hail with some of these. You can even get some flash flooding. So that'll be a threat for the early to middle part of the afternoon until the system starts to move east and away from us. All right, so if you look at the big picture again, radar view, good severe storm moving through far eastern Oklahoma. It's the one that started in southern Oklahoma this morning. Produced a little bit of hail with it, just keeps on trucking on. The low is out here we talked about. You can see the wind field plotted on the map. So you have these southeast winds that are kind of curling back into it. Then you get kind of a northwest wind. So that's how you get that area of low pressure pulling in the wind field. On the backside, you get that north-northwest wind. So that's the area of low pressure. That's where you have the atmosphere kind of coming together at the surface. And then what comes together has to go somewhere. And it can't go down in the ground, so it's got to go up. And when it goes up, that creates lift, and that's what helps to get those storms going. And so it's very critical where this low ends up. And for today, it looks like it's going to be just south of Oklahoma City. All right, let me see what else I want to show you. We can show you the tornado parameters. So this is, let's see what hour I'm on, 20. Okay. This shows where the best, if you're to mix all those severe weather ingredients, all right, best shear, best cape, best instability, the best kind of stuff to feed thunderstorms, to A, produce supercells, and then B, of those supercells, produce a tornadic environment. The brighter the color you see on the map, the better that environment. And you can see how it's kind of still, like I said, I-35 corridor, and then in Oklahoma, along the Red River, then points east. So even kind of curling on up toward Tulsa, it's going to kind of ride that warm front wave, wherever that warm front wave sets up. So it's going to have to give or take here, because the model won't get it exactly right as far as mile by mile, but it's going to have the general ballpark idea. Now as we go into the latter part of the afternoon, you'll notice more of these bright colors show up, more purple, even some brighter reds and pinks in there, indicates parameters even more favorable. So what does that look like? Well, if I were to plot a sounding, this would generate some concern. What it has is a few things here on the thing that we like to point out to as a meteorologist. You have somewhat of a sickle-shaped hodograph. All right, so that means that the wind shear is extremely conducive. In other words, how it turns with height along with speed to produce potential tornadoes. You can also look at it in this view, which is what I like to call out a lot of times. It's easier to see. You have a wind out of the south at the surface, and as you go up with height, that wind turns with direction to the west, and the wind speeds stay high in strength. There's some other fun features on these forecast soundings that we have now, such as what they call a slinky appearance. It's the same thing. You're just taking another look at the same idea. What happens is the model tries to produce what type of storm we're going to see. So the possible hazard type is what they call a PDS tornado. Now in this particular case, that would indicate a very strong or even violent type tornadic atmosphere. All right, so here's the effective STP layer. We just looked at that STP product. That was the significant tornado parameter, and the red line here is off the charts. So it kind of puts it into the EF4 plus category. Now, is this always accurate? No. Is it a guidance? Yes. Does it indicate potential? Yes, for sure. Will it always be realized? No. But when you see these kind of things, it gets your attention. All right, that means you take it serious. If we look at here at the sounding itself, for the lift and condensation level, it's down here in the noise. Or not the noise, but in the ground level. It's one of those deals you can almost reach up and touch the sky. All right, so just a few hundred meters off the ground. Good environment for producing tornadoes. A really good sounding profile with the temperature and the dew point. Very moist here at the lowest 1,000 kilometers. So in other words, these will not be moisture starved. These are going to be in the situation to where you got plenty of moisture to work with. So that's not a limiting factor. Hence the lower condensation level and the lower cloud bases. Cape values around 3,000 joules, plenty adequate. Doesn't have a cap in place to kind of offset storm development. Everything else looks good there. And then we look at the, let's see, yeah, the shear is around 2 to 300 on the helicity value. So plenty of turning, plenty of fuel for the fire. So in other words, any storms that do manage to develop in southern Oklahoma and then moving into the eastern parts of south central Oklahoma in these sweet spot areas, according to the model data, it looks like a very potentially interesting setup for a strong tornado. And the winds were adequate for one of those that would last a while. In other words, not be a quick 10-second wind, but one that would last several minutes. So that's the concern for today. Now, the Storm Prediction Center has not upgraded the risk from enhanced to say moderate or high, and they don't have to do that. So don't get lost in the category warfare that you'll see sometimes on Twitter in the weather community. If there's a risk, there's a risk. All right. A lot of times, what those things try to do is put those in numbers. In other words, will be just a few storms, or will be a lot of storms, more of a coverage type deal, so that there's more impact per square mile probability. In other words, within this many miles, there's going to be a tornado versus within this many miles, a tornado of one particular point. So, in other words, you could have a tornado in a slight risk, and you can have a tornado in a high risk. The difference is we have one, or you have a setup where you can have many. In this particular case, there's no model indication of many. There's only model indication of a couple. And it's easy to track a supercell, and usually you get one or two in an environment. It's very rare to get a whole environment filled with supercells. That doesn't happen that often. So it's when you're having a small batch of a couple storms to watch, there's typically no need to put a high risk out there for if you're trying to forecast, the amount of people affected over, a certain area. All right, so hopefully that was some clarity in the difference between some of those categories that you see. Let me see, what else can I show you? By the way, this is technical discussion. You're not going to get this watching the guys on TV. So I have more time to talk about this kind of stuff, and so I get to educate you more on why things happen, what to look for, and then this in turn should help to reduce your anxiety and provide a little bit better understanding, so that you realize, okay, no, we're not all doomed. No, it's not going to affect everybody, and then what to look for in particular areas. So this is the forecast for around 3 o'clock or so in the afternoon, and as we talked about, you have that ribbon of moisture, the dew point values that move right up the chain here to I-35 corridor from Texas, and then you get the southwest winds coming in, and then these winds here out of the south. All right, now the model is interesting here. If they can stay more out of the south, like this model indicates, you get less of a potential for A, a tornado, and B, more than a couple storms to fire. It may even have trouble firing one storm. You need really good convergence, especially after in an atmosphere where it's been worked over a little bit. Now the current situation, let's go take a look at that. All right, see, if I look at the current situation, these winds are not due south, like the model said. They're more southeast, and that is a huge difference maker when it comes to trying to produce storms later in the day. So this will be something to watch very carefully. But we're only talking about a few hours from now, so we'll have to see how things progress. But right now, all indications are favorite area still stays remainder the same, just south of this little boundary, which is running right about through Norman to the south and west of there a little bit, along I-35, and then into eastern Oklahoma for this afternoon. Now, with that warm front stretching up here, something like this later in the day, you get some of those storms that may ride up the warm front. So Tulsa, you'd probably still be on the cold side of it, which means hail for you. Whereas if you travel a little farther south, you might be more in the tornado risk. Let me see here. I think that was about it. So here's again, look at the big broad picture. We don't have any development southwest storm-wise just yet. But if we look carefully, it looks like we do see some echoes trying to show up. Oh, that was one thing I wanted to look at, and I did not pull that up, so let me do that. Yeah, let's do this. All right, so you can see all the cloud cover across the state. And let me throw on, nope, this guy here. Rivers, counties, highways, interstates. It's kind of give you a little better idea of wish they had some towns on here. That's the only thing they don't have. But if you look down here, this is Oklahoma City, I-35 right here, intersection of 40. 40 runs this way, 44 runs this way. All right, so we're looking down here in southwest Oklahoma. The low is right here, and that's under this cluster of storms. So you see how this, or I should say cluster of clouds. So you see this is the triple point forming, and there's already trying to get some lift here. So which means this atmosphere here is primed to go way earlier than what the models think. The fact this is already forming. Now this is going to move pretty quick. So by the time something gets going, it may not be until it hits Comanche County, say maybe in this area over here. We'll have to wait and see. But regardless, it doesn't change where the favored dynamics are, and that's going to be, like I said, once it gets to about this period, or excuse me, this point on the map from about here, and then southward, and then eastward is a favored area of instability and all the other parameters for the model data. Can't say, it doesn't mean that you can't have something happen before then, just that's where the best parameters are showing up in the data. Regardless, though, this clearing is where the instability is rapidly increasing here in southwest Oklahoma. I could probably take a look at that in the mesoanalysis. Let me see here. Turn this on. Okay, so this is looking at some of that instability we talked about. This is interesting because this kind of goes along with the most aggressive model I posted on my blog. If you remember in my blog on Sunday night, I talked about Wednesday's setup for potential for tornadoes and where the best parameters would be. It would be southern Oklahoma, south central Oklahoma, and then how the models would fight as to whether the starting point is more southwest or is it more central or southeast. That was the only thing to kind of iron out. But I posted a more aggressive model, which had southwest, and this is where that aggressive model is paying out 3 days early. So here's the low up here, and you can see the Cape values are into the 2000s, 3000s south of that. So this is where we're getting that instability to develop to help to produce these storms, which may go a little earlier than expected. So even as I'm sitting here giving you this forecast, I'm watching things evolve and change on the fly, which is interesting just to note and see how that works. Let's see here. Let me do something. Let me look at another parameter, and then I'm going to probably let you go. I do plan on doing some cut-ins this afternoon. So here's the blue areas. This is highlighted blue areas where you get a lot of lift in the atmosphere. It's where some mid-level lift is coming together, which is why you're starting to get those clouds bubble up and now turning into a shower out here in southwest Oklahoma. In the current look at the significant tornado parameter, we'll plot that on here. So the significant tornado parameter that we showed you in the model data for this afternoon around 3 and 4 o'clock now currently is centered southwest. So everything is a snapshot in time in an hour. And I don't have all data to show you every hour, so I usually just pick a highlight midpoint and kind of expand upon that. So if we were to start currently in the current sense of things, this particular storm environment, once it moves eastward toward Lawton in 44, it starts to tap into that environment. Now, like I said, for this middle part of the afternoon, this environment shifts and then increases to the east, closer to I-35. So that's what I'm saying. It's not out of the ordinary, or it is probable that one of these storms, if they can get going in time, once they reach about this area, for them to potentially produce a tornado. It's just going to be more favorable as they move east because this environment will move east with it. So it's going to kind of ride into that environment. So if the two kind of go in tandem, that storm matures right into that point, and the two kind of ride that environment east together, that's not a good thing. All right, that would be a long-lived scenario for a significant supercell storm with significant hail, up to tennis ball size, and yes, a long-lived potential tornado, and one that would be on a stronger side. So that's how these things can kind of evolve with time. So all these are nice forecasting tools. and then we break them down so that we can kind of give you the best information, and then we kind of have to just wait and see how things evolve, and then track it minute by minute once you get into what we call a nowcasting mode. So this is almost a nowcasting mode. I'm talking about it now. So it's not so much what we call a forecast, which is a few hours from now. It's more of like, okay, what's happening this very second? What's happening this next minute? So when you watch, broadcast where you're cutting in for severe storms, the weather service is sitting back like what I'm doing with all the radars and maps, and they're analyzing stuff and they're triggering buttons for this warning and that warning. That's a nowcasting approach. All right. I think that's pretty much what I wanted to show you. So I hope that was informative. Hope you got something out of that you feel more confident at what's going to happen, where it's going to happen, what you can expect in your neck of the woods. So this will be our first tornado day, you might want to call it, for Oklahoma. There's been other tornado type days, but they've been in across the southeastern part of the country and just east of us. Arkansas has had a few, Texas, so it'll be our turn here for today. We'll set the stage to where we'll start to get into that drone mode for May. So we'll have more days like this to come, and over kind of a larger area. We're really hyper-focused into a small section of Oklahoma today, but kind of giving you all the details that we have for that. All right. Well, I don't have any time for questions. I gotta get back, but I hope this lunch hour weather update was informative, and I'll probably be seeing you again. Next time around, it'll be a live cut-in, because I do cover tornadic storms. I don't cover just generic thunderstorms, and most of the time I will not cover a hailstorm, because there's only so many times I can just stand here and go, yep, there's more hail. Yes, there's more hail. If you live along this track, more hail. That bores me to tears. Hail's not pretty, and it's not good. It does cause damage to roofs, but as long as you're not out there playing in it, it should not possess or pose a health or life and death issue for you. Stay out of it and you're fine. Tornadoes obviously are a different animal, and so that's why I cover those as best I can. All right, so we'll do that again later this afternoon. Meanwhile, be safe out there. Know what your safe place is for today if you need it. It's always going to be the center part of the home or building, lowest floor, basement if you've got one, which is rare, storm shelter better, not everybody has one, closets, bathrooms, kind of get the deal. All right, we'll talk again soon. You guys be careful out there.